In order to solve this system of linear equations with the addition-elimination method, I first need to decide which variable I'm going to eliminate, and I'm going to decide to eliminate the x terms. In order to eliminate those, what I need to do is, using the multiplication property of equations, I need to make the coefficient in front of these x's opposites of each other. What I'm going to do is I'm going to make the top equation have a x coefficient of negative 40, and I'm going to make the second equation's x coefficient positive 40. So negative 40 and positive 40. So which means I need to multiply this first equation by 5. I have to do this to each term. And I'm going to multiply the second equation by negative 8. And again, I'm only focusing on the x coefficients, but every term has to fall in line here. So when I multiply the first equation by 5, what I'll get is negative 40x plus 45y equals negative 255. And then for the second equation, every term I'm going to multiply by negative 8. So negative 8 times negative 5 is a positive 40x. And again, this is what I was looking for, the x terms to have opposite coefficients. But moving right along, then I'll get negative 40y. And it's going to equal a positive 240. Alright, now that my x coefficients are opposites of each other, now when I add these two equations together, what I get is my x's cancel each other out, or 0x. 45y minus 40y is 5y. And then negative 255 plus 240 is negative 15. And then I can simply solve this for y by dividing both sides by 5, so I get y equals negative 3. So I have my y value. All I'm going to do now is take this y value and plug it into one of my original equations. It doesn't matter which one I use. I'll use this second one here. So all I'll get is negative 5x plus 5y, but y now is negative 3, equals negative 30. I'm just going to solve this equation for x to get my x value. So what I get is my x value is 3 and my y value is negative 3. And that is the solution to the system.